to mine gold. Why not? Yeah, because cyanide is not a very safe substance. So we know, you've heard of carbon monoxide poisoning. So carbon monoxide has this structure. This is the structure of carbon monoxide. And it turns out that carbon monoxide will bind to the iron in our hemoglobin, in our blood, and displace the oxygen. Okay, so that's how we get carbon monoxide poisoning. So the same thing is true with cyanide. So cyanide actually has a similar structure as carbon monoxide. The only difference is that the cyanide has a minus charge. So this actually also binds to the iron and hemoglobin very readily, and this will displace the O2. So this is how a person can get ill or die from carbon monoxide or cyanide poisoning. Okay, so it displaces the O2 from the hemoglobin, and well. Now note that this is actually an equilibrium reaction. So if a person is suffering from carbon monoxide poisoning, how can you reverse that process or reverse that reaction? Okay, so let me write the reaction this way. Okay, so we have, we'll call this one hemoglobin. So you have the oxygenated hemoglobin, and this reacts with CO, or Cn minus, and that produces okay, so if carbon monoxide is present, note that the carbon monoxide is going to displace the O2 to form this carbon monoxide hemoglobin compound. And then O2 is going to be floating around. So how can you reverse carbon monoxide poisoning? You want to give the patient or the person the oxygen, because when you give the person oxygen, what's going to happen? The reaction is going to flow in the reverse direction. Does it take a lot of cyanide or CO to suffer from carbon monoxide or cyanide poisoning? No. So based on that information, would you expect oxygen to bind better to hemoglobin or CO to bind better to hemoglobin? Yeah, so actually CO binds much, much better to hemoglobin than oxygen does. Okay. Let's keep on going because I want to. Okay, so here's the chemistry of swimming pools. Spring break's coming, maybe you got to go swimming. So note that swimming pool chemistry is sort of complicated. There are several reactions going on. So chlorine gas reacts with water to form HOCl, which is hypochlorous acid. It also forms hydrochloric acid. Now usually bleach rather than HOCl is added to the swimming pool. And we know that bleach is added as a disinfectant to kill bacteria. So when bleach dissolves in water, it forms the Na plus and OCl minus ion. Once the OCl minus ion is formed, that reacts with water. And what would you expect these two products to be? Okay, so OCl minus reacts with H2O, and that forms. It forms what? Okay, now OCl minus is actually a base. So if this is a base, that base reacts with water to form hypochlorous acid and OH minus. Okay, so this is this base hydrolysis reaction. Once HOCl forms, then that can produce. Okay, so this is an acid. So the acid is going to dissociate the H plus and OCl minus. Okay, so there's quite a bit of chemistry going on in the swimming pools. So the chlorine is actually not Cl2. It's either going to be the OCl minus or the HOCl. So it turns out that HOCl is more effective in killing bacteria than ClO minus. And does anyone know why HOCl is more effective in killing bacteria than OCl minus? So the way it kills bacteria is that it has to pass through your cell membrane to get inside the cell. And once either the HOCl or OCl minus gets inside your cell, then it kills those structural features inside your cell, like the what are they called? I can't remember what they're called. Yeah, the ribosomes and whatever else. Because I haven't taken biology class, so I don't know what they're called. Whatever they're called, those things inside your cell. So anyway, why is HOCl more effective than OCl minus in killing bacteria? Okay, so again, what's happening is that if this is your cell, and then this also is your cell membrane, either the HOCl or the OCl minus has to pass through the cell membrane to get inside the cell. So why is HOCl more effective in killing bacteria than OCl minus? Yeah, so it has to do with the ease of getting through the membrane into the cell. So it turns out that this passes through the membrane more easily than OCl minus, but does anyone know why? Because of the charge. Yeah, so note that an uncharged or neutral substance will pass through the membrane more easily than a charged one. Okay, and then to do for reactions 3 and 4, we can actually look up and calculate because here's more pool chemistry here. This is actually from poolcenter.com. Here they talk about, here's what they say, as the efficacy of chlorine is greatly influenced by the pH. So as the pH of your pool increases, the killing power of your chlorine decreases. At a pH of 6, 96% or so of the potential out of each pound of chlorine, and at such a low pH would wreak havoc in all the surfaces of the water. In other words, pH 6 is too low. It actually starts reacting with the tile and the concrete in the swimming pool. It's actually not too good for your eyes either, or for your skin. Move the pH up to 7 and the efficacy of chlorine drops to 73%, but raise to 8 and it drops dramatically down to 21%. So the perfect pH level seems to be 7.5, where 50% of the chlorine is as HOCl, hypochlorous acid, and then the other half is as the hypochlorite ion, OCl minus. So why is the perfect pH for a swimming pool 7.5? And then, based on the information given in this paragraph, what do you think is the equilibrium constant for this reaction here? So one reason that the perfect pH for a swimming pool is 7.5 is because yeah, your eyes have pH about 7.5. Yeah, because really, if it's lower, if it's more acidic or makes then your eyes start burning, it's not going to feel good to your eyes. Okay. Based on this information here, what do you think is the pKa of this reaction? So again, you said earlier that it's HOCl going to H plus OCl minus. So what do you think the pKa of this reaction is, given this information we have here? And George, why do you think it's 7.5? Yeah, because what George says at pH 7.5, 50% is as HOCl, 50% is as OCl minus, and we know that at the pKa, at that pH, we know that we have half of the HOCl and half of the OCl minus. Okay, so it does turn out that the pKa is equal to 7.5. Okay, here's another thing about swimming pools, which I didn't know until I found this information out. Have you ever smelled that chlorine smell in a swimming pool? Yeah. When you smell that chlorine smell, what do you think about? Is the pool clean or is it dirty? Yeah, so when you smell that chlorine smell, I think most people think, okay, good, they must have just treated the pool must be clean. Turns out it's not quite so. It says here that chlorine reacts with ammonia and ammonia-like compounds that are formed from organic waste, for example, pee, or something worse, to form these chloramine compounds. So, for example, here's ammonia, reacts with chlorine. Here's an example of chloramine. Okay, this compound here. These chloramines block free chlorine, and that means that the free chlorine cannot oxidize bacteria, and the chloramines actually result in that chlorine smell. So the chlorine smell isn't actually from Cl2, it's actually from this compound here. So really when you smell that chlorine smell, it's because someone has peed in the pool. Yes, if you smell that smell, then you have some choice on it. Then the other thing too is that note that chlorine molecule dissociates to the chlorine atom when it reacts with sunlight. In other words, the UV radiation from the sun will break this chlorine-chlorine bond and form chlorine. Anyway, these chemicals, cyanuric acid, are added to stabilize chlorine. And actually, here's how it stabilizes chlorine by forming this compound here. Okay, so if you go swimming during the break in a pool, you'll know what to smell for.
Yeah.
And then let me give you one more piece of information. So you know that in one of the waste products from urine is urea, and then urea is this compound. So note that urea is one of these ammonia-like compounds, which is in our urine. One of the waste products from the body. You note also that I'm not sure if you've ever read anything on how to survive if you run out of water. They say you drink your urine. You shouldn't really do that because then you're drinking urea, and that's actually toxic in your body. You don't really want to be drinking what's a waste product in your body. So that's not really good. Okay, so on that note, last note, well, there's some things about oxalating. Last note, let's take a quiz. Since we're running out of time, I'll let you take this quiz in a group again. So if you want to work with another